This video will cover section 5.3, inverse functions. Now, I know this video is coming after 5.4, and I know that natural log and e to the x are inverses. So typically, a lot of people will show inverses and then show how natural log and e to the x are inverses of each other, and then use that rule to find e to the x. However, inverse functions is not something that's very pushed on the AP exam, so I'm going to show it to you. That is for other inverse functions other than natural log and e to the x, and how to find the derivative of an inverse function. Especially if you don't know how to find the inverse of a particular function. Okay, so let's just recap what an inverse is. So a function has an inverse if it is one-to-one. In other words, if it's a graph, passes both vertical line test and the horizontal line test. So one-to-one means the graph passes the horizontal line test as well. So a function must be strictly monotonic, and monotonic means strictly increasing or decreasing in order to have an inverse function. Okay? So we're going to first just get practice in finding the inverse function, and then we'll look at the derivative. So to find the inverse function for this function, f of x equals the square root of x minus 5, what I typically do is just switch the y and the x and then solve for y. So f of x will become x, and then x will become y, and then we simply solve for y. And also, before we do this, I should have mentioned about our definition of whether you can take the inverse or not. So this is the square root of x minus 5, so it'll look something like that, which is one-to-one, so the inverse doesn't exist. All right, so we're going to first square both sides, getting this, and then add 5, so we have x squared plus 5. However, when I take the inverse, remember graphically what that means is you're flipping this across the line y equals x. So this will look like that, which you can see is part of the parabola, x squared plus 5. However, it restricts the domain. So remember that the domain and the range for inverse functions are flipped. So if the domain of the square root of x minus 5, sorry, let's talk about the range, I'm sorry. If the range of the square root of x minus 5 is x greater than or equal to 0, y, then the domain for x squared plus 5 then would be x greater than or equal to 0. You can see that graphically. So that's something that you want to watch out for when you're taking inverses, is you have to define your inverse function with its restricted domain. So also something else that I want to point out to you, I said y, but if I called my original function f, that means that my inverse needs to be called the inverse of f, or it looks like f to the negative 1 power. So I'm going to say the inverse of f is the function x squared plus 5, but only when x is greater than or equal to 0. Okay? All right, so now let's look at the derivative of an inverse function. So let's call f and g and say that they are inverse functions. So actually, before taking the derivative, I just want to show you that you can prove that f and g are inverse functions by taking the composition of them. So f of g of x, if you get back x, then that means that they are inverse functions. So using that knowledge, if you then take the derivative of both sides, those derivatives should be equal. So here I'm taking the derivative of the composition of f and g. Remember, keeping in mind that f and g are inverses of each other. So the derivative of a composition will be f of g of x, and then times g prime of x. And then the derivative of just x will be simply 1. So if I were to be asked the derivative of an inverse, so remember, g is the inverse of f. So that means I would want g prime. So if I solve this for g prime, then you simply get 1 over f prime of g of x. And that right there is the derivative of an inverse function. All right? So now let's apply that rule. Okay, so let's say that f and g are inverse functions, and f is x cubed plus 3x minus 1. Now, you do not want to find the inverse of f, because if you try to do that, you actually can't do that with the cubic function. So you have to go about this a slightly different way. So I'm going to find g prime, the derivative of the inverse function of f, and evaluate that at 3. And actually, typically when you're asked to find inverse function derivatives, you're typically not asked to find the actual derivative, the equation, but you're typically asked to find an evaluation, so at a certain point like this. Okay, so just a couple of things that we know about inverse functions. So if I want to find g of 3, so we're going to say that g of x contains the point 3 and then what we're looking for, right? So we're looking for some y value. Or sorry, that's not what we're looking for, but there is a y value that goes along with g. All right, and so if g contains the point 3 and then some y value, then f, which is its inverse, is going to contain the point that's something and then 3 as the y value. So what I need to find, if we go back and remember what our inverse function said, if I want to find g prime of 3, then going back to our other page, looking at the definition there, then I want 1 over f prime of g of 3. All right, so I need to figure out what g of 3 is in order to find my answer. Well, what is g of 3? G of 3 is when f of x, y value, is also 3. So to find that value, we need to find the x value of f when its y value is 3. So we're going to go back to our original function f and plug in 3 for y, and we're going to have to solve for that x value. Now, we run into the same dilemma that I had before with solving for x here, and actually with this function you can't really solve for x, so we're going to just kind of guess and check. So that's pretty easy. If you're trying to equal 3 with this equation, x can be only a very limited amount of things. So try 1, and so you get 1 plus 3 minus 1, which is 3. Okay, so if x is 1, then that is when we get a y value of 3. So we're going to put 1 here for our x value of f, which means that when g is 3, then its y value is 1. Okay, so now that we've found that y value, we're going to plug that into here, and so our g prime of 3 is 1 over f prime of 1. Okay, so now, by that reasoning, I need to find f prime and evaluate that at 1. So f prime is going to be 3x squared plus 3. So then f prime of 1 is going to be 3 plus 3, which is 6. Therefore, the derivative of g prime of 3, g prime of 3 is simply 1 over 6. And that's how you typically will do a derivative with an inverse function. Okay, so looking at our last example, so that's given a function and how to do it with that. But what if you're given a table of values? So you have selected values of f and f prime, and f and g are inverse functions to find g prime of 1. So going off the definition we just learned, g prime of 1 is going to be f prime of g of 1. Okay, so we need to figure out what g of 1 is. So remember what I wrote up in the first example. I would say that g contains the point 1 something, and so f contains the point something 1. So we start with our f, we know, and we want to say, okay, when is f equal to 1? At what x value is f1? Well, here is when f is 1, so the x value is 2. So then g contains the point 1, 2. So then I can go back here and substitute that in. And so I want to find f prime of 2, looking at f prime of 2. So now remember, 2 is now my x value. So if I want f prime of 2, then f prime of 2 is negative 3/5. So then I have 1 over negative 3/5, or negative 5/3, and that is my answer. Okay, so that's all the examples, really. I will say that, like I said at the beginning, this inverse function is not something that's very prominent on the test. You may see a problem, or you may not, actually, on the AP test. But that is how you take the derivative of